Hi, I'm Dr. Bear, and today I'm working in MATLAB. I'm going to show you how to write a MATLAB application or app. MATLAB apps are very useful for studying a fairly complex problem where you want to see variations on a system and you see how different parameters can affect the system. A nice thing about MATLAB apps is that they give you instantaneous feedback. Additionally, you can share apps with other people, even if they don't have MATLAB. You can package the app and give it to someone else. So we're going to show you how to make a simple app like this one. In this one, I have a couple of cosine waves. One is a reference and the other one I can vary. I have a slider to vary the frequency and maybe a text box to change the amplitude of the red cosine here. And you see how the system responds as I vary these different parameters. So this is a simple app. You could make a much more complex app. This app is one that I've used to study molecular computing systems. So I'm designing molecular circuits here, and I can see how these schematic depictions of these computational molecules respond. So here red represents negative charge and green represents positive charge. So this molecule has some uncovered fixed positive charge and a mobile electron. This app has several tab groups where I can change parameters. I can add molecules to the system here. The field points in one direction. If I change its direction, the molecules will respond differently. Let's change that positive 90 to negative 90. But that's complex, so let's not focus on that. Let's just build this simple app. So we'll close this app so it's not a distraction. I'm going to close this app designer and we'll close this app and let's figure out how to do it from scratch. So a great starting point is to have a script in MATLAB that plots something. So this is a script that plots cosines. So it's a symbolic plotting. So I had defined t as a symbolic variable. I have parameters for the reference sinusoid and parameters for the variable sinusoid. Right now I've hard-coded them so that the amplitude is 1.5 volts and the frequency is 1.25 hertz. And then we define these functions of t for time, so the reference cosine and the variable cosine. And then I use plotting commands. So there's the fplot command for symbolic expressions. So there's the reference cosine. I set its line width, and then the negative 1 to 1 specify the limits of the plot. So in fact, we can just run this. So if I click here and make this function the active window, I can click here on editor and then we'll click run. My figure will come up on another screen. Actually, it had some other things in it, so let's run it afresh. So here it is, it's figure 1. And then one thing that's nice here is I'll dock the figure. It's a little bit bigger now, but what I can do is I can change things and you can see how it changes. So I'll change here, make this a 1.75 for the amplitude, run it again. And you see the blue one looks like it got smaller, but in actuality the red one got bigger. We can vary the cosine frequency. I'll turn it up. So that'll make a time compression on the variable cosine. So now what we want to do is we want to put this in an app. Again, we have a script as a starting function. I'll also point out that I have all these plotting commands down here. They pertain to this figure. We'll have to modify them when they're in the app. But let's start by making an app. By the way, I may sometimes call this a GUI. GUI stands for graphical user interface. So to make a new app, what you do is you go to the Apps tab and then Design App. This will bring up the app designer. Here's the app designer. Since we're going to build a basic app only. Let's just click a blank app. Now we have this window. It's fairly complex looking. There are 3 panels, the center panel, the left, and the right. Right now we're looking at the design view. This design view is good for dragging various components out onto the main canvas there. Let me get rid of that for a moment. What you see, this is the background, the figure. It's called a figure. So you'll see here a hierarchy of objects. There's an app object here. As part of the app object, there's a figure object. It's actually a UI figure object, UI meaning user interface. And so if I drag an axis out onto it, the axis now becomes embedded in the UI figure. So MATLAB calls this a parent-child relationship. So the figure is the parent, the axis is the child. I can resize it. And then I can also bring out a slider. So let's just do that. You can have the slider horizontal, or you could have it vertical. So you can see here, if we've selected the slider, I can change its orientation. So I'll just click this to orient it vertically. Maybe I'll move it down a little, and I'll change this text to be frequency. And it's always good practice to specify the units on things. Again, more on the attributes of this slider. I want to set a minimum value of 0 because negative frequencies don't really mean much. And I'll also reduce it to 5 for the upper limit. Okay, so that's maybe enough on the frequency slider. Let's just run this for a moment and see what happens. I think I'm going to need to save it, so let's just save it first. I get to choose the location where I'm saving it. This is a demo. I'm going to make this code available to you, so I'm going to put this in a new folder, and I'll call it cosine demo. The app gets this extension ML app. Okay, now that I've saved it, I can run it. So I click this run button. It may take a moment for the figure to come up. It's come up on another screen, so I'll drag it over. Here it is. It's a blank figure, and the slider, I can move it, but it does nothing. So now we want to change that. When the app opens, you want it to plot the reference cosine and the variable cosine. And when we move the frequency slider, something should happen. The variable cosine should update. So let's make that happen. So I'm going to close this app. And the first thing that we need to do is to provide code to do this. So we'll use the code view, and we're going to take the code from our script and we're going to copy and paste it in. So what I like to do generally is I go to the code view, and when I click the code view, I can do callbacks, functions, or properties. That's what happens in this left pane. And we'll talk about what these are, but I'm going to define a new function for a moment. And it's going to contain all the text of this other script that I have. So let's click here. We can just click plus, so it adds a function, and there it is right here. So I'm going to call it calculation engine. And it has one argument, app. If you're unfamiliar with writing MATLAB functions, I have another video I'll link in the video description. But this app refers to the app itself, and we'll use that variable to reference the various parts of the app, and I'll show you how that goes in a moment. So I'm going to get rid of the results. We don't need an output. So I'm going to take and copy and paste the code from my script. I don't need the commented thing I put at the beginning. We'll just paste it right here. And another thing I can do is Command A. On Windows, that's going to be a Control A, and then Command I on Mac, and it indents everything. So it helps to see what are the bounds of the function, and it's just generally helpful for readability. So here's that content. Here are the parameters and such. Notice that the amplitude and the frequency are hard-coded. We're going to have to change that in the future. But one thing that we have to do right now is we have to plot in the axes. So let's go back to the design view, and there are a few things we have to do. So like this axis right here, if I click on it, it's UI axes. So what I want to do is I want to give it a better name, a more meaningful name. So I'll call this here main axes. This might be useful because there may be multiple axes on the plot. I want to visualize different things, and one axis is the main axis. So that's what we're going to call this. I have to go back to the code view, and the calculational part of the code can stay the same, but the plotting commands have to change. So what I have to do here with fplot is I have to specify app.main_axes. That's the target axes where all these plotting commands are going to take place. So we have to modify all the commands so that the first argument now is main axes. So here where it's hold on, I now use parentheses. The first argument is app.main_axes, and then we can use on in quotes. So another fplot, I have to paste in app.main_axes, again referencing the new axes that I named. So here hold off. And maybe I didn't specify, but what happens here is this first plot command plots the reference sinusoid. Without hold on, the second plot would overwrite the first sinusoid. So I use that hold on, so I keep both together. And then I use hold off. That way, when we plot to the axis again, things can get updated and we're not just adding lines to the plot. And then GCA stands for get current axes, but we're going to change that. We can just change it to app.main_axes. And let's see, grid, main axes on. We also have to add main axes as the first argument for the X label, the Y label, and the legend. Legends are always important so that the user can understand what they're looking at and know what it is. Okay, so there's the calculation engine. If I run the app again, nothing will happen. I can just show you that. The reason that it doesn't do anything is that we haven't actually called our function. So now I'm going to move this aside, and we have to call our function. So the way we make that happen is through callbacks. So callbacks are functions that are executed whenever events happen. So like a button press, you move the slider, something like that. So let's go back to the design view for a moment, and let's work on the frequency slider. One thing I want to do in the design view is I want to set the initial value for the frequency slider. I want it to have a value of 1. And if we go back to the code view, we can now add a callback to this slider. So if you click here, callbacks, we'll use a value changed function. So this is a callback that executes whenever you change the value of the slider. There's a value changing function, and if you are dragging the slider, this is getting executed. That's an excessive computational burden in this case. I just want to do the calculation once I drop the slider, once I drag and drop it. So we'll just use the value changed function. And so to do that, you click this down arrow, and since it doesn't have one, click add value changed function for callback. MATLAB creates this function in the code for the app. And here, it's a stub function, basically, like just part of a function. It gives you code to extract the value from the slider. I don't really need that here. I'm going to comment it out. But what I do want is this handle right here. This extracts the value. So it's it refers to the app, the frequency slider, which is embedded in the app, and then the instruction is to get the value of the slider. So I'm going to copy that. And what I want with this callback is I want the calc engine to be executed. So I have tab completion, so that's kind of nice. So I'm basically calling this function that I wrote in the callback to the slider. Okay, so now I can save it. And I had to modify this callback slightly. So I'm going to go to the functions calc engine. I'm going to click it. And what I need now is the value of the frequency for the variable cosine should be this. Rather than being hard-coded, it should now get the value from the slider. That's why calc engine needs this app variable, so that it knows what it's pointing to when you refer to app frequency slider value. Okay, so now this will be executed every time we change the slider, and it's going to get the value of the slider, store it in the f variable, and let's see how that works. So I'm going to click run, and watch what happens when I move this slider. I get this plot, and the variable sinusoid changes after I move the slider. So now we're getting instantaneous feedback. Now, one thing I would like to improve is that you noticed when I started the app, the plot didn't automatically appear. Well, we'd like that to appear, so let's fix that. So the way to do that is I click on the UI figure itself, I believe. No, I have to click on the app, actually. So I click on the app. This is a property of the app that we're going to add. It's a callback, basically, for the app. So cosine demo, that's the app name. We'll click callbacks, and then I can click here and add startup function. So the startup function gets executed when the app starts up. So let's just put in here calcengine.app. I will save this and run it. And when the app comes up, here it is. The plot has automatically been drawn upon app startup. So again, I can vary the slider, change things. All right, and then one last thing I'll do in this video. Obviously, you can make the app as complex as you want, but let's add that edit box for the amplitude. We'll go back to the design view. We see the app. We're going to select here an edit field numeric. So we'll slide that in. Numeric is what we want. Let's give it an initial value of 1. Oh, that's a mistake. I don't need to do that. I'll hit delete and get rid of it. So let's click here on this object. And if I go edit field numeric, I'm going to rename it. So let's call this, let's change this text to amplitude in volts. I'm going to set the value to 1. So that's where it'll be when the app starts up. The limits, yeah, I guess it could be negative infinity to infinity. That's okay here. And the name has already been changed, so that's fine. So now let's go to callbacks, add a callback for value changed. And I'm going to comment this out. I don't need it. I'm going to get this so that we can extract the value from the slider, or the edit box rather. And now we're going to go back to the calc engine function that we wrote. And again, what we're changing is the amplitude. So here's the amplitude of the variable cosine. I have it hardwired to 1.5, but that's where we extract the value from the edit box that we added. I only need one semicolon there. I can save it. And let's start up our app again. Okay, now I can modify this amplitude. So I'll just lower it a little bit. And when I hit enter or return, something should happen. Nothing's happening. Let's see here. Why is that not working? Let's go back to the callbacks. I can look at the thing here, the callback for our edit. I can look at the callback for our edit box, and you can see what happened is I forgot to put in this call to calc engine. So let's put that in. And I believe I can save this because all of this code gets executed whenever I modify the app. So I think I can just change it here without closing the window. Let's put here 0.85. Oh, okay, there. Now it's changing. We'll make it bigger. Now the red amplitude is bigger. Let's make it bigger still. Okay, so that's basic app design. So what we had to do here is we get a new app, we add an axis, we name it appropriately so that we can refer to it later. And then we had a function. So I'm in code view and I added a function. Basically, it's like the calculational engine for this app. This gets run every time an event happens in the app, and that's through callbacks, right? So you associate callbacks with the various components of the figure, and then you have to make sure that the callback to each of these figures contains a call to this calculation engine. So let's click on amplitude edit field, and if I click this arrow, it'll take us down to the callback for that. So it's the amplitude edit field. Okay, there it is, and we're calling calc engine. So that's basic app writing. I hope you found that helpful. See the video description for links to the code and links to other videos related to app design in MATLAB. I'll include at least another video on functions and another video on plotting. If you found this helpful, please subscribe to the channel, share the video. Thanks a lot, and happy coding.